So today we are going to discuss the concept of temperature and heat. In this unit we will like to discuss the basic concepts associated with temperature and heat. We will also discuss the different modes of heat transfer and how the heat calculation is being done for the heat transfer. And in this section we will also like to throw some light on the phase changes process. So now we are going to start. First, what is temperature? How the temperature is defined? So the temperature is the measure of how hot or cold a substance is. Temperature tells us that the temperature tells us about the substance or object, what amount of heat is associated with that, how hotter or cooler is that. In science, temperature is a measure of the average kinetic energy of the particles in an object. In other terms, the average kinetic energy of the particles in any object also tells about the temperature. If the average kinetic energy of the particles in any object is higher, it means that object has the higher temperature. And if the average kinetic energy of the particles in that object is lower, then temperature is comparatively at lower temperature. So the average kinetic energy of the molecules of any object also tells the situation of temperature in that object. Now, as an object heats up, its particles move faster. As a result, its kinetic energy and its temperature increases. As an object cools off, its particle moves more slowly. As a result, its kinetic energy and temperature decreases. So, when you heat a particle, for example, when you heat water on your gas cylinder or stove, you see at initial there is no movement in the water molecules when you put on the gas cylinder. After heating for several minutes, you can see there is a movement in the molecules of the water. And when you heat further, when a limit temperature limit is achieved, you so that the particles and molecules of the water which is at the bottom gets energy, heat energy, and will move towards the surface. So the as soon as the temperature increases, particles kinetic energy will also increase. So the average kinetic energy of the particles is also a measure of a temperature. Now for the example we can discuss. Now you can think like this: if you are running, you are moving quickly, you have a high kinetic energy, and you feel very warm, your temperature goes up. So, in daily life, when you run, you see your body temperature gets hit up and you sweats. So, it means when you move quickly, you have higher kinetic energy, you have higher temperature. Now, if you are very cold, however, you start to shiver, why would shivering or moving around help you stay warm? So, in cold winter season, you start shivering. Why you start shiver and why you rub your one hand against other hand? Because the rubbing action, the average kinetic energy, average speed of the molecules of that body increases, and that causes the increase in temperature. So this is the basic natural phenomena, real life example behind the temperature. So how to measure the temperature? So most common instrument which is used to measure the temperature is called as thermometer. So thermometer is an instrument used for measuring temperature and is based on the thermometric properties of matter. So thermometer is instrument which is used for measuring the temperature. Now, measuring instrument, it utilizes the physical properties of materials to accurately determine temperature. Now, most important term is the thermal expansion. So it expands with increase in temperature, contact with decrease in temperature. So basic thermometer in which you add the mercury. So when you temperature, when this material gets temperature, it expand and the reading will show in your thermometer. And when it gets cooler temperature, it will contact. By the this means by this principle, we can measure the temperature of any body. Now for the temperature scale, we have set different reference point like ice point of water and freezing point of water. So we have two reference point. First one is called as ice point. Ice point is taken as the freezing point of water, and second one is the steam point, which is called as boiling point of water. So basically the three different types of scales, or other way we can say that three different units are majorly used for measuring the temperature. Now look at this. These are the three temperature scales: Celsius, Kelvin, and Fahrenheit. So steam point, which is we have earlier defined, the steam point we have defined is the boiling point of water. So you know the water boils at 100 degrees centigrade. So in Celsius, we are reference point, that is steam point is at 100 degrees centigrade, and ice point at the point when the water freezes. So you know water freezes at 0 degrees centigrade. So these are the two reference points. So at different scales, you can see that the steam point is 100 degrees centigrade, whereas in the Kelvin scale, it is 373 Kelvin, and it is in Fahrenheit scale, it is 212 degree Fahrenheit. Similarly, ice point is 0 degrees centigrade. At in the Kelvin scale, it is 273 Kelvin, and at a Fahrenheit scale, it is 32 degree Fahrenheit. So you can see there are two reference point in Fahrenheit. This ice point is 32 and steam point is 212. For the Celsius, the reference point, which is ice point, is 0 degrees centigrade and steam point is 100 degrees centigrade. And in Kelvin, you can see here 270 to 370 Kelvin. Now, these three scale can be converted into each other by using these formulas. So we can see here the different types of conversion formula. If you want to calculate Celsius to Fahrenheit, you have to multiply into Celsius by 9 and divided by 5, and you have to add 32. So if you want to convert Fahrenheit to Celsius, subtract 32 minus 32 into from the Fahrenheit and multiply by 5 and divide by 9. You will get the centigrade. Similarly, if you want to convert Celsius to Kelvin, you have to add 273 into Celsius, then your temperature will convert it into Kelvin. Similar way, if you want to convert Kelvin to Celsius, you have to subtract minus 273. You have to subtract 273 from the Kelvin, then the temperature will be in Celsius. So you can use these formulas to convert the one kind of temperature, one scale of temperature in the another scale of temperature. So how to convert? Let us see some example based on that. So example 1 is the melting point of silver is 961 degrees centigrade. What is this temperature in Kelvin? So you can easily calculate, temperature is Kelvin can be get by adding 273 in temperature in Celsius. So you have 961, you have to add 273. Now you will get 1234 Kelvin temperature you will get. So 961 degrees centigrade, if you want to convert in Kelvin, you have to add plus 273 and you will get 1234 Kelvin. Now we are going to another example. Pure iron melts at 1800 Kelvin. What is this temperature in Celsius? So you have the temperature in Kelvin. So if you want to convert this temperature into degree Celsius, then you have to subtract 273 from Kelvin. You will get in degree Celsius. So we have the 1800 Kelvin. We have subtract 273 from that, and you will get 1527 degree Celsius. Okay. See another example. On a winter day, the temperature is 5 degree Fahrenheit. What is this temperature on Celsius scale? Now you have to convert the Fahrenheit into Celsius. So the another formula here, you have to add 40 and then you have to divide by 1.8, and after that you have to subtract by 40. You will get the temperature in the Celsius scale. Okay, so after all you will get minus 15 degree Celsius. This is very simple calculation, you can do easily. Now the next concept we are like to discuss is kinetic theory of matter. So all the matter is composed of tiny particles molecules that are in constant motion. So we know that in any particles, in any molecules or any matter, there are small types of different small particles is associated and they are structured. So in this diagram you can see in solid all the particles have different volume and different shape. Liquid had the different volume but indefinite shape, and gases had neither nor the different volume and neither the different shape. Now solid particles are closely packed with little motion. Solids have definite volume and definite shape. Liquid particles are loosely packed and have some motion. Liquids have definite volume and indefinite shape. You put liquid into any kind of pot and it will get the shape of that pot. But solid had the definite volume and definite shape. Gaseous particles are far apart from one another and have great motion. Gases have indefinite shape and indefinite volume. So gases has both indefinite shape and volume, and its particles are very far from each other and it have a great motion, higher motion among the solid liquid gas. Now increase in temperature increase the motion of molecule in any state. We have discussed already, when you increase the temperature, the motion of any particles, motion of molecules in any state will increase. For example, evaporation of liquid results from loss of fast moving particle at the red surface. When the water or liquid evaporate, the fast moving particles will come on the surface. Now we are going to include the concept of heat with the temperature. So heat is the thermal energy that is transferred from one body to another because of temperature difference between the bodies. So heat is a thermal energy which transfer from one body to another body because of temperature difference. So when there is a temperature difference, there will be heat transfer when the body will be in contact. So heat is the thermal energy which transfer due to the temperature difference. Heat flows occurs from higher temperature to lower temperature. So temperature is the average kinetic energy of molecules in a substance. Now we want to check this concept. So consider a cup of hot coffee and a frozen lake which has a higher temperature. You have two things, a cup of hot coffee and a frozen lake. And the question is which has the higher temperature? So hot coffee has a higher temperature than frozen lake. Okay. Now the question is which has more heat? So frozen lake has more heat because it contains many more particles. So the concept behind that is that temperature of the coffee will be higher, but when we ask the amount of heat, then amount of heat will be higher in the frozen lake because it has more particles, and more particles will consume more amount of heat, will absorb more amount of heat. So heat has the frozen lake has higher heat, whereas the cold coffee, whereas the hot coffee has the higher temperature. Okay. So from here you have to remember this concept that it is not means that higher temperature have the higher heat. So the heat will depend upon the other factors also. So what are the other factors on which the heat depends beside the temperature, we will discuss in the next sections. Now the another concept. On a cold day, when someone leaves a door open, it is often said that person is letting in the cold air. Is this correct? It means the question is asked in a winter season on a cold day when someone leaves a door open. Door is not closed, door is open, and it is said that we say that person is letting in the cold air. Person is allowing the cold air to come in the room. No, the basic concept behind that is heat travels from higher temperature to lower temperature. It is said that what is often said is person is letting heat to enter in the room, but no, the warm heat, the higher heat of your room is going out and you are feeling cold. That is replaced by the cooler heat, cooler temperature air. So heat is going out rather the cold in. So behind this concept, you can say that you always know that the heat transfer from higher temperature to lower temperature. So heat will not cooler temperature will not enter in your room, but conversely heat will leaving from your room. So, how the heat is measured? Heat is a physical quantity that can be measured. The science of heat measurement is known as calorimetry. So, the quantity of heat is proportional to the amount of substance, you can say the mass of substance, then its temperature and the nature of substance. These are the three factors on which the quantity of heat absorbed or released is depends. Now the SI unit of heat is joule, and another convenient unit which is generally taken for the heat is calorie. So see this example. There is a two pot and two hot plate which is heating these pots. One pot has water 1 kg and another pot has water 5 kg. So it takes 5 times as much as heat to boil 5 kg of water than 1 kg. So question is, which container requires more heat to reach the same temperature? So you have the two types of container, which has one has a water of mass 1 kg, another contains water of mass 5 kg. So which container will take more heat to reach the same temperature? So automatically it is clear that the container which has 5 kg, which has the more molecules, will take more times and more 5 times more heat to reach the same temperature. So from here a very good point comes, mass and heat are directly proportional. So mass and heat are directly proportional. From this practical example we have defined this. Now another concept. We have the same hot stove and we have the two pots. One has the fewer amount of water or any liquid, another has the more amount of liquid. So using the same amount of heat, which container reaches a higher temperature? The question is, the same amount of heat is supplied to both the container, so which container will reaches higher temperature? So although the same amount of heat is added to both containers, the container with less water gets hotter. It is very clear the container which has the very less amount of particle will get more heat, will get high heat supplied is same, but it has less amount of particles molecule, so it will reach the higher temperature fastly. So from this concept it is also coming out that mass and temperature are indirectly proportional. So one concept which is earlier defined as mass and heat are directly proportional, but mass and temperature are indirectly proportional. This is a basic difference, very important difference between the temperature and heat. Now we are going to discuss a specific heat concept. So different material absorbs or lose heat differently. Now the third amount, we have discussed three factors which impact the heat. First one is the mass, second one is the temperature, third one is the property of material. So property of material which defines the heat released or absorbed by the particle is called as a specific heat. So different materials absorb or lose heat differently. That is, the feeling of a hot apple pie may be too hot to eat, whereas the crust is not. It means it is saying that if you eating crust and apple pie, it is very difficult to eat. Hot apple pie may be too hot, whereas the crust is not, because they has the different heat capacity, which is called as a specific heat. So, the specific heat of a substance is the amount of heat required to raise temperature of 1 gram of that substance by 1 degree centigrade. The amount of heat which is required to raise the temperature of 1 gram of any substance by 1 degree centigrade is called as a specific heat of that substance. The unit of specific heat is joule per gram degree centigrade or calorie per gram degree centigrade. So now we are going to see how to calculate the heat. So you know that heat depends upon the three factors: mass, specific heat and change in temperature. So heat changes are measured using calorimeter. Conservation of energy. The amount of heat lost by one body is gained by another body. You know, law of conservation of energy, that energy can neither be created nor be destroyed but it can be converted into one to another form. So law of conservation of energy says is also applicable here. If two body comes in contact, one is hotter and one is cooler, then the amount of heat lost by the hotter body is equal to amount of heat gained by the another cooler body. So heat gained or lost is based on the three quantities. Heat equals to mass of substance into a specific heat of substance into change in its temperature. So heat, if you want to calculate the heat transfer, so you have to multiply mass by its specific heat capacity of substance, which is C, and its temperature difference delta T. So here we get the formula to calculate the heat. H equals to mc delta T. So now we want to do some numerical question on this. So first example, how much heat must be supplied to 20 gram of tin to raise its temperature from 25 degrees centigrade to 100 degrees centigrade? A specific heat of tin is 0.055 calorie per gram degree centigrade. So numerical is mass is given 20 gram. Temperature difference, you have to raise the temperature from 25 to 100. So temperature difference delta T is 100 minus 25 is 75, and C is given. You have to simply apply the formula H equals to mc delta T, and you will get the heat required to raise the temperature from 25 to 100 degrees centigrade. Okay, now second example, calculate the specific heat of a solid if 1638 joule of heat raises the temperature of 125 gram of solid from 25 to 52.6 degrees centigrade. Now here you have to calculate the specific heat C. So listen my dear, if you have want to solve any question numerical problem, you have to correctly read the problem at least two times. After reading the question, you have to first find out what is asked in the question. So it is asked to calculate the C. Now you have to note the given data. So given data is mass is given, which is 125 gram. Temperature difference, you have to raise the temperature from 25 to 52.6. So delta T is 52.6 minus 25. You will get the temperature difference of 27.6 degrees centigrade. Now a specific heat is asked, and the heat which is transferred is given is 1638 joule. So you know the very simple formula H equals to mc delta T. So you know have to calculate C. So C equals to H equals to m into delta T. You have the H, you have the m, you have the delta T. It is not difficult to calculate. So the value of C will be calculated as 0.475 joule per gram degree centigrade. So these are the example small numerical problems which shows how the heat calculation is done. Now the next concept we would like to discuss in this is the phase change. So when matter releases or absorbs energy without a change in temperature, phase change occurs. So if any matter releases or absorbs energy and the temperature of the matter or particles or object remains the same, it means there is a phase change between the matter. Without changing the temperature, if the matter releases or absorbing the energy, that there will be definitely a phase change. Phase change means the state, three state, solid, liquid and gas will change. So what is the term we would like to define? So liquid if get energy will convert in the gas and that process is called as evaporation. When gas releases energy, cools, then it will convert into the liquid and that process is called as condensation. Now if solid gets temperature melted into liquid, that process is called as melting, and if liquid cools temperature and freezes, that process is called as freezing. If solid gets heat and directly converted into gas, then that process is called as sublimation, and if gas releases heat and directly convert into the solid, that process is called as deposition. Okay, so arrow says, if this arrow says solid gets energy, means energy in, if arrow is upward means energy in, and arrow downward means energy out. Now we have discussed melting. Melting is the conversion of solid into liquid. Evaporation is conversion of liquid into gas. Condensation, condensation is conversion of gas into liquid. Freezing, freezing is conversion of liquid into solid. Sublimation, sublimation is conversion of solid into gas. And deposition, deposition is conversion of gas into solid. Now for the particular case of water, we see the concept temperature versus heat. So when the heat is added to ice, when heat is added to ice, it absorbs the heat without any change in temperature, thus causing the phase change. If you add the heat in the ice and there is no change in temperature, it means the ice will melt and it will convert into liquid. That is the phase change from solid to liquid. Similarly, when heat is added to hot water, a phase change occurs without any change in increase in temperature. So when your water is boiling at 100 degrees centigrade and now you are adding constantly extra heat in that, you will see there is no change in temperature. Temperature is 100 degrees centigrade constant, but there will be conversion of phase. The liquid phase will get converted into the gaseous phase. So this is the concept of phase change. Now next concept comes latent heat. First we will like to discuss the latent heat of fusion. So the quantity of heat required to melt 1 gram of solid is called as latent heat of fusion. Okay, the amount of heat which is required to convert 1 gram of solid of any substance into the liquid, that amount of heat is called as latent heat of fusion. So particularly for the case of water, for the case of ice, if you want to convert 1 gram of ice into liquid, you have to give the energy of 80 calorie per gram. So latent heat of fusion for ice is 80 calorie per gram. Next concept is latent heat of vaporization. So the quantity of heat which is required to evaporate 1 gram of liquid is called the latent heat of vaporization. So 1 ग्राम लिक्विड को आप वेपर में कन्वर्ट करने के लिए जितना हीट रिक्वायर्ड है, दैट इज कॉल्ड एज latent heat of vaporization. Okay, for the water latent heat of vaporization, it means the to convert the 1 gram of water into the liquid, you have to give the 540 calorie of energy. So latent heat of vaporization for water is 540 calorie per gram. Now heat during the phase change. So if you want to calculate the heat during the phase change, you have to use the flowing formulas. The amount of heat released or absorbed during the phase change depends on the amount of substance and its latent heat. So, what amount of energy heat you have given, released or absorbed during the phase change depends upon the amount of substance and its latent heat. So if you want to calculate the latent heat of fusion, then that is H equals to m into Lf, and if you want to calculate the latent heat of vaporization, then H is m into Lv. Okay, so if you we are going to do a numerical based on this also. So how much heat is required to melt 50 gram of ice at 0 degrees centigrade? If you want to melt the 50 gram of ice at 0 degrees centigrade, how much heat is required? So as I said, my dear, you have to see all the given data. So data is given 50 gram of ice. Latent heat of fusion is 80 calorie per gram. For the ice, we have to remember that data. For the water, for the ice, latent heat of fusion is 80 calorie per gram. You have to require heat, so you know the formula now. You have to apply H equals to m into Lf. M is given, Lf is given. So we will get the heat, which is 4000 calories heat is required to melt 50 gram of ice at 0 degree centigrade. Now another example, how much heat is required to vaporize 50 gram of water at 100 degrees centigrade? You have to vaporize 50 gram of water at 100 degrees centigrade. For that you have to give the heat. So how much heat is required? So data is given, you have to simply apply the formula heat equals to m into Lb, and you will get the amount of heat. For this case it is 27,000 calorie. Another example, uh, it is saying calculate the calculate the amount of heat required to change 20 gram of ice at 0 degrees centigrade to water at 10 degrees centigrade. So look, here is a twist. Here you have to see that there is you have 20 gram of ice and you have to convert at water in 10 at 10 degrees centigrade. So there is a temperature difference 0 to 10, and also there is a phase change. So you have to wisely take into the consideration of both type of heat required. So total heat required for this case is, first you have to melt the ice, that is melting process, that will be the phase change process. During this process there will be no heat, there will be no temperature difference, and after the heat the ice will convert into the water. You have to supply heat to reach the temperature of 10 degrees centigrade. So first heat is required to melt the ice, and another heat is required to warm the water. So heat is required to melt the ice, you can calculate by the formula m into Lf. Latent heat of fusion, you can calculate this. After that, uh, to warm the water, you know the very well-known formula. Heat warming water equal to mc delta T. You have the mass 20 gram. A specific heat of water, and the temperature difference is 0 to 10. So you will get and both 1600 calorie and 200 calorie will be added. So total 1800 calorie heat is required to convert 20 gram of ice into 20 gram of ice at 0 degree centigrade to water at 10 degrees centigrade. So this is the concept. Now we would like to discuss the mode of heat transfer. How the heat transfer takes place from one body to another body. So when there is temperature difference between two objects, heat flows from warmer to cooler object. So, heat energy transfer occurs by one of the three methods. First one is the conduction, second method is called as convection, and third method is called as radiation. So, these are the three methods through which heat transfer from one body to another body. So, let us discuss these three methods in detail. You can see from this diagram the process: convection, conduction, and radiation. So wood is burning, and from that burning wood, a iron rod which is kept in the hand is also getting heated. That heat from iron rod which is being transferred to the hand is the mode is called as conduction. And you can see the hand heat is also transferred to the hand, that is the mode of convection, and also see in the radiation. So what is conduction, convection, and radiation, we are going to discuss in the next. So first one is the conduction. Conduction is the transfer of heat by contact between two objects through molecular collision. So in conduction, the very important point is contact between two objects and then the molecular collision. Collision. If there is contact between the two objects, one is the at high temperature, one is the lower temperature, there will be the molecular collision between both and heat will transfer, and that mode is called as conduction. Metals are good conductor of heat while glass and wood are poor conductors, insulator. Conduction is transfer of heat between two objects that are touching. If there is a contact between the two objects, and that from that contact there will be molecular collision, and that will cause the transfer of heat from higher temperature body to lower temperature body. For an example, you can take the fast moving particle in an oven collide with the slow moving particle in the frozen pizza, and this causes pizza particles to move and making the pizza hotter. Next, convection. Convection is the transfer of heat by actual motion of molecules. Okay, liquid and gases transfer heat mainly by the convection. Convection is type of heat transfer that occurs only in fluids such as water or air. Very important point, by the mode of convection only water and fluid from water and fluid heat transfer is possible. So fluid is heated, rises and replaced with the cooler fluid. This flow creates a circular motion known as convection current. This causes wind and weather changes. So convection is the transfer of heat by the actual motion of molecules. If there is actual motion in the molecules, then there will be the heat transfer most mainly in the liquid and fluids, and that mode is called as convection. Okay, so if for example in convection we can consider boiling of water. Boiling of water, that is molecules that are denser move at the bottom, with while the molecules which are at less denser move upwards, resulting in circular motion of the molecules, so the water gets heated. If you warm the water in your gas stove, that is also the example of convection, where the bottommost particle gets first heated, and when they heat it their weight becomes lighter, they will move towards surface, and that is replaced by the another slower, that is a very known example of convection. Now radiation. So radiation is transfer of heat without molecules. Heat from the sun reaches to the earth through the radiation. Radiation is the heat transfer for which no medium is required. It is without the molecules. It is only type of heat transfer that you can feel without touching the source. There is no contact is required. It is heat transfer through electromagnetic waves. It is the heat you feel from the sun coming off the hot pavement, steam from the boiling pot of water, warming your hands above fire. These are the example of radiation. You can see here the example of conduction, convection and radiation. So conduction energy is transferred by direct current, convection energy is transferred by the mass motion of molecules, and radiation electric energy is transferred by electromagnetic radiation. Now the concept of thermal expansion. Thermal expansion, all matters expand when heated due to molecular motion which causes them to separate from each other. The more molecular motion, the more expansion in the volume. So, gases has the higher thermal expansion than the liquids than the solid. So, solid has the most highest thermal expansion after than liquid and after than solid. So, thermal expansion of solids. Solids expand upon increase in temperature based on the three factors. If you heat the solid, it will expand, it will depend upon the three factors. First is the increase in temperature, second is the original length, and third one is the type of material. Okay. A practical use of thermal expansion of metal is use of bimetallic strip operation in thermostat. So in thermostat, bimetallic means the strip which is made of two different metals. You can see here iron and brass. When you heat, there will be change in the shape of this bimetallic strip. When you cool this, there will be the shape change. So this is the thermal expansion and contraction, thermal expansion when heating and contraction when cooling. Thermal expansion of water. When water is at 0 degrees centigrade, when water at 0 degrees centigrade is heated, it first contracts and then expands. Water has a smallest volume at 4 degrees centigrade. So very important point here to be noted, and it is very important question, what when the water has its smallest volume, so it is not the 0 degree centigrade, it is 4 degrees centigrade. So water has the highest density at the rate of 4 degree centigrade. We would like to see the more some more concept of water. The thermal behavior of water is important in preserving aquatic life in colder climate. As water cools on the surface, it sinks due to its high density and allowing for circulation. Okay. Now, at the rate of 4 degrees centigrade temperature is less equal 4 degrees centigrade, it becomes less dense and rises to the surface. So, freezing occurs at the top and allowing for marine life to exist below the surface. So you have read the news in the colder areas when the temperature becomes below the 0 degree centigrade, the water of the rivers, like for Dal Jheel in Kashmir, melts, sorry, freezes, and temperature becomes 0 degrees centigrade. So what about the marine lives like fishing and other things which are fishes and other animals which are living in that sea? So the phenomena is that the temperature at the surface gets very cooler and freezes, but at the bottom still the temperature is above 0 degrees centigrade, and the temperature is above 0 degrees centigrade that causes the water to remain in the liquid state at the bottom, and that's why the fishes and other things remain alive in winter days. Now we will light some thermal circulation. The difference in a specific heat of water and land cause the land to warm up more quickly during the day. So you can see that you can now know the concept of specific heat, which has the higher specific heat capacity will absorb the more heat. Though in the marine areas where the sea and land, so land which has sand has different specific heat capacity, and the sea has different specific heat capacity. So the less dense warm air increases and is replaced by cool air from the sea, causing a sea breeze. So there is a formation of sea breeze in the day. The specific heat of water and land causes land to warm. So land has the more specific heat, it will absorb more energy in the day, but water has the less specific heat. So water has lesser temperature, cooler temperature, and the temperature will flow. Higher temperature of land will go up, and the cooler temperature from the sea will come and replace this. This will create a sea breeze. This is called as sea breeze, which is normally seen. You can see the cities, you can know the cities which is placed near the sea areas has the average temperatures throughout the year. Now what happen in the night? During the night, the land cools faster than the sea, reversing the process and causing a land breeze. In the night, when sun goes off and the temperature becomes lower, the land, so what happens? The sea, which has absorbed the energy throughout during day, will release the energy, and the hot energy from sea goes up, and the cooler energy from the land side will replace that at the bottom. So with this formation is called as land bridge. Okay, so these are the concepts we have discussed today. Hope you have enjoyed and learned a lot. Thank you very much.